So the video interrupted. In any way, to come back on metabolic pathway. Metabolic pathway are multiple chemical reactions that occur to achieve a very specific outcome. That can be the product of that reaction. For instance, the production of a given amino acid, let's say amino acid called tryptophan. Now, in the synthesis of tryptophan, there is going to be multiple reactions. Each reaction is catalyzed by a specific enzyme, so that we have a cascade of reaction, so that at the end of the series of reaction we do have tryptophan. Now, what happened in non-competitive inhibition, we have tryptophan, as it becomes abundant, is going to be used as the inhibitor, what we call an allosteric inhibitor. So tryptophan is going to come and bind on one of the enzyme that is involved in the pathway. In general, the allosteric competitor is going to come and bind on either the first enzyme in the pathway or the second enzyme in the pathway, or somewhere within the pathway, but definitely before the end. Okay? Now, this is going to cause a conformational change of the enzyme, which is going to prevent the enzyme to do its job. Now, that control of the enzyme by the end product of a metabolic pathway is called allosteric inhibition. Okay? That allosteric inhibition, or otherwise called negative feedback, is the most common process by which cells control the activity of its enzymes. That is a very important detail to remember. So understand what an allosteric enzyme is very important. Understand how an allosteric enzyme is controlled, it's also very important. So an allosteric regulation can be a feedback inhibition by shutting down the allosteric enzyme. And as a reminder, this is the most common process by which a cell controls negatively its enzymes, so that the level of activity can be controlled. That being said, well, you don't only have allosteric inhibitors, you also have allosteric activators. Allosteric activators are going to be the opposite. In other words, when in a metabolic pathway a product is produced, the presence of that product is going to trigger even more production of the product, which is going to increase the amount of the product as the cell needs it. So let's go back to metabolism. Metabolism, we say that metabolism is the sum of all reactions of synthesis or anabolic reaction and all reactions of hydrolysis or catabolic reaction occurring in the cell. Now, anabolic reactions are endergonic reaction. They require input of energy, they use up energy, while catabolic reactions are going to release energy, they're going to produce energy, and there is a close connection between metabolism and anabolism. The energy that is produced during catabolism is going to be used to fuel chemical reactions that occur during anabolism. So, the biochemical pathway, I already kind of mentioned those biochemical pathway. It's a series of chemical reactions. So I'm going to refer you to slide 29, where you have initial substrate. That substrate is going to be converted into a product that is going to be a substrate for another enzyme that is going to convert that substrate into a product, which itself is going to be a substrate for another enzyme. At the end of the day, you have an end product. And coming back to allosteric regulation or negative feedback, the end product can be can shut down the activity of enzyme 1. So I did tell you about the negative feedback, so I'm not going to come back to that. Some enzymes can be